Okay, do we have any questions over the graphing? I asked you to do, did I ask you to do these? We didn't do, hold on. What did we do last time? We did 2 of those, and then I gave you some questions out of the book, right?
Yeah.
Okay, so any questions over the questions? No? You were able to get them all? Yeah. No problems? No. Okay. So there were still some that we hadn't looked at that we need to address. So let's take a look at this one up here. F of x is negative x cubed plus 9x over x squared minus x minus 30. So remember that the goal here is to graph this rational function, right? And what would be your first step? Factor everything out, right? Make sure you have a rational function and then factor. So what would you like to factor out of the top? You want to go negative x? Yeah. That's fine with me. I was hoping you'd say that. And that will help you see the difference of squares there. And then on the bottom, x minus 6, x plus 5. And let me go the top a little bit more here, x plus 3, x minus 3. What should I be looking for right now? If you can cancel anything. If I can, then I'm going to have what? A hole wherever that factor is equal to 0. Do I have any holes? No, no holes. So I can proceed. So what was it that we looked for next? X-intercepts. And how do we find the x-intercepts? Just the numerator equal to 0. And since it's completely factored, it's going to be pretty clear, I think. Yeah. What are 0, negative 3, and 3? So x equals 0, comma, negative 3, comma 3. I'll just put them all together in one answer right there. Those are our x-intercepts. Next, verticals. So to do that, how do I go about getting my verticals? Denominator equal to 0. Sounds like y'all got this. You take the day off. Two of these, right? 2 verticals. Can anyone tell me right now how many test points I'm going to have? 6. I'm going to have 6 test points. All right. What's next? Horizontals. Now, how did we do the horizontals last time? What were you saying? Wasn't what? Were you saying something?
No, I was thinking.
You forget about everything else. So
Yeah, when you just figure out how it behaves.
You just look at like the highest powers, right? So like here it's like x cubed. So this is behaving a lot like x cubed over x squared, which is really behaving like negative x over 1, right? Like if I cancel out an x squared, this is acting like negative x. That's what it seems to be behaving like, right? And so what we did last time is we said, all right, well, this horizontal thing tells us our left and right behavior, right? So what would happen if I go out to the left on my graph? I'm letting x get really big, right? X is approaching a positive, very large positive number. What if I take a very large positive number and then multiply it by a negative? It's a very big negative number, right? Doesn't that mean that my graph should do something like that? As I go out this way, you're telling me that it's going to behave like negative x does. Negative x should go negative, shouldn't it? Yeah. Yes? Sure?
Well, that's the way.
No, I'm just making sure you're making the connection. I'm going out this way, which means I'm plugging in a really big positive number. but it's behaving like this. So make a real big positive number here and then multiply it times negative. It's going to be a really big negative number. Big negative numbers live down here, right? So my graph at the end should start to dive down. Okay, so I'm going to say this. For my horizontal, as x goes to infinity, right? As x goes to infinity, my function, f of x, goes to negative infinity. That's different than what we did last class, right? Last class, it actually was turning out to be a number. Like one time it was 0, and then the other time I think it was 1. Did we do that one? Did we do the x squared minus 4x over 2x? No?
We did x squared minus x minus 6.
Where is it? It's not up here.
It's like at the very top.
Is it? Oh.
There you go.
We did that one? And this one? Oh, okay. All right. So, you sure?
Yeah, we did 3x plus 5.
Okay.
So we did the first
Okay. So if you go back and look at those, on the first one, when we did this little thing, it basically went to 0, and that told us the x-axis. Yeah. And then the second one I may have made up, I think it was a 2. Was it a 2 and a whole?
Yeah,
Okay.
it was 2.
The horizontal was 2? Okay, so this is very different. What's your question?
I think I have two questions.
Okay.
Okay, first one, if it says negative x, then how come we're not going left?
Okay, look, this function right here, f of x, is the output of the function, right? The output of the function is this. And when x gets really big, this stuff is insignificant. It's just this over this. If we do that, it turns out to be negative x. So what we're saying is that the function, the outputs, are behaving like this. This is what's coming out of the function. Okay? So now I would like you to plug into the function a very big positive number. The output will be -1 times your input.
Okay.
Got it?
That makes sense.
Okay, which will give you a negative output, which means that I will start going down.
Okay.
Does that answer one of them or both of them?
That answers one of them.
Okay, what's your other one?
How do you apply as x reaches infinity, fx reaches negative infinity, like as a horizontal?
It won't be. That's the thing. Okay, so we're not going to have a flat line this time. We're actually just going to have, it's going to behave more like a polynomial, and it's going to dive down. Okay, so we said in the beginning, when I first introduced you, I talked about 1 over x, and we said it had these certain properties, and it had these horizontal asymptotes. Both examples I gave you last class had horizontals that we flattened out to. This is an example of a rational function that does not have a horizontal asymptote. It actually just behaves more like a polynomial. Good? So there's really like 3 things that can happen here. You can either get the x-axis, you can get like y equals 2 or -1/2 or something like that, or you can have none. Those are the 3 different possibilities. All right, so that's what happened as we went out to the right. Can someone tell me what happens if we try and go out to the left? The opposite. Why?
Because it's going to be negative times negative is a positive.
Yes, you're plugging in a very big negative number, and then you multiply it times -1, it'll be a very big positive number. So it'll go to positive infinity. So this way it should go up. So the way I'm going to write that is as x goes to negative infinity, the function's value goes to positive infinity. Understand that? Does that make sense? Ariel?
Kind of. It'll click eventually. I don't know.
Okay. All right. Maybe I can show you just another approach. Might help. Okay, so here's something else we can do. If this right here doesn't turn into a number, like if this is confusing to you, like what's happening here, what you could do, and you may not like this, I know that you're not going to like this, you could do long division. Okay, so let's just look real quick at this, and let's just do a long division on that. We're actually, I'm going to ask you to do this later, so you may as well do it now. If I did long division, what would I put up here to start?
X.
Negative x.
Right.
Negative x, right? Understand? And then
That'd be negative x cubed.
you got negative x cubed
Plus X.
plus x squared. Oops, I didn't leave an x squared here. I shouldn't have done that. Plus 9x. So positive x squared, right? And then plus
Plus
30x.
and
Then come through and change it, right? Plus, minus, minus, and what would you get?
all the x3 cancels.
Gone.
Then that's going to be a negative.
Negative x squared,
And then that's going to be a negative 21.
21x. And now
You can go 1.
1, negative 1 into there. And we go through again. I'm out of room on the bottom. I apologize. I'll do it anyway.
The x is basically
Negative x squared, positive x,
positive x, so it'll be 20.
and then positive 30. Then I come through and I add down. When I add down, I get negative 20x and negative 30. And that's where I have to stop. So I'm going to have negative 20x minus 30 over my divisor. Okay. I don't know if this helps at all, but
And basically it's going down anyway, just minus 1.
this is basically the same function, right? This and this are identical. If x gets really big, let's try this again. Just talk about the remainder for a second. What does the remainder act like?
Negative
Negative 20x over
over x squared.
x squared. And this is really like negative 20 over x. What would happen if x gets really big here? This would become very small, right? So this whole thing, as x gets big, goes to 0, right? The rest of the function looks like this. Okay? Do you know what that looks like as a graph? What is this? Just negative x minus 1. What is it? It's a line. What's its slope? Negative 1. So it looks like this. Okay? Notice that the side goes down and this side goes up. That's basically the same thing. You know how I was saying as we go out this way, it goes down, and then you go out this way and this side comes up? You can tell all that information by doing long division and just investigating what this does. Whatever this does at its ends is what our original function does at its ends. Okay, I hope. Pardon?
The long path.
Yes,
Because you basically get the same answer.
that's right. That's right. It's a little bit longer, but maybe it makes a little more sense. I don't know. That's the important thing. Everything's always easier to learn if you understand it. If it's just memorizing something and trying to repeat what someone else is doing, then it doesn't stick as well, right?
Same concept, we're still not going to try to figure out where it starts to go down or where it starts.
That's right. That we're just saying we can do later, just not in this class. Okay, so I'm going to kind of summarize the horizontal asymptotes this way. I know it goes up on the left. I know it goes down on the right and there. And I'm going to state here no horizontal asymptote. There is no line that I'm going to flatten out to. It's going to act like a polynomial at the ends. What was yes?
So all that linear line that we created, does it help us find those in?
It helps us find the end behavior.
Yeah, the in behavior.
Yes, that's all.
What if the in behavior is up, up, or down, down?
It could be.
Then would we just not be able to find a linear line for it?
Then it might be that when we did the long division, we had a quadratic, and the remainder went to 0,
So then it either went up
and then it would be up, up. Yeah, good question. That would require, though, that this up here be like x to the 4th, and this be x squared, so that when we divided, we'd have to come through with our first one would be an x squared, and there we would get our parabola. Okay, what was the next thing you were supposed to do at this point once you found all this? Just plot everything, right? Make sure you have all your information written down and put it all on a graph. Ah, man, I just erased the part I wanted to keep right here. I want to keep this right there. Okay, so here's my graph. I have these. These are what on my graph? X-intercepts. So what are they when I draw them?
Like you can actually put a point on.
Points on the x-axis, right? So 0, 3, -3,
And they all cross.
and they all
Cross.
cross? What do you mean?
Like they're gonna go
The line's
through
gonna
the
cross
line.
through each point.
How do you know?
Because
Because the
when we
powers.
got the x-intercepts, it was to the 1.
Okay,
And-
I'm glad you're bringing that up.
And because it's an odd, it's gonna cross.
That does not apply for rational functions.
No.
Okay? We have to, that's only for polynomials. The way we determine what's going to happen there is by test points.
Oh,
Okay? That's a good thing you said that.
okay.
And the reason why is because rational functions, there's more involved. You have stuff in the denominator and numerator that could affect the sign. So, yes.
So then, what's stopping this from being classified as a polynomial? Is
We
it
have
just
to
the fact
lift
that it's
up our
divided by
pencil.
something?
Because a rational function is a polynomial divided by another polynomial. That's what a rational function is.
Okay.
Yeah. Okay, next was the 6 and -5, and these were vertical asymptotes.
Yeah.
These I'm going to draw with red because they're really not part of my graph. They just help me draw it. So 6 is maybe out here, like that. And -5 is over here, like that. And then I can't really draw a horizontal asymptote because I don't have one. Like, I just need to remember the left side goes up, the right side goes down. Okay? So next would be test points, right?
So we're gonna need
So tell me what test points you want to use.
-2.
Okay, so -2, that would give you one in here.
-2, -2.
2 would give you one in here between these two.
And isn't that all we really need since we know it's going to go down and then up on the sides?
No, we need a total of how many?
4, 6.
How many x-intercepts do we have?
3,
Verticals?
2,
So one more than that. 6. You need 6 test points. -6, so something out here on this side, -6, good. 7 over here, yes, that will work. Something in between 3 and 6, 5.
And -4.
-4. Do you get the idea now that it's got to be like in between every piece of information that you have and on the outsides? And now with these test points, I get to plug them into the original function, don't I? Yes? And that's the original function factored. And I recommended you use this because then you can just figure out what the signs are going to be. So let's start with -6. We'll just work our way across. If I plug in x is -6 into this, -6 is +6, right? -6 plus 3, negative, right? I don't care about what the value is. -6 minus 3, negative still. All over, -6 minus 6, -12, right? Negative. -6 plus 5, negative. The numerator should be what? Positive, right? Two negatives become a positive. Positive and positive is positive. Or you could say positive and negative is negative. Negative and negative is positive. Bottom? Positive. So that means right now that I can come over here to -6 and I can put a point up. And then I continue. -4.
same.
So what do we have? Positive first. -4 here. Negative. -4 here. Negative. Over. -4, negative. So that's negative here. And then here, -4 plus 5. Positive. That's different.
Positive or down.
So this one's going to be a positive over a negative, and that's going to be negative. This one was positive. And remember last class I said it doesn't just switch every time, right? But actually in this case it does. All right, so I'm going to just not do the rest and just show you. So at -2 you should get a positive. At 2 you should get a negative. At 5 it's a positive. And at 7 it's a negative.
And that gives you the left, it goes up on the left and then down on the right.
Yes, that should be everything we need. You all ready to draw it? At this point, it's just a process of thinking through what's possible, what has to happen, right? So start at the far left point, and you must draw out to the left, and you must draw to the right. So let's start by moving to the left. If I move to the left, what has to happen? Has to go up. Remember our left and right behavior? Remember we said the left side has to go up? So this is going to have to go up. What about as I go to the right?
It can't go past the -5.
Can't go through that. Those force us up or down, right? Which way here? Down?
No, there's no x-intercept.
It doesn't have an x-intercept. It's got to go up. So it's going to look like this. Now it should be curved. There's no like sharp corner here. It's curved. Okay. It's almost like a little parabola over there. Not quite, but that's kind of the way it's behaving. And then once you get to a vertical, you have to pick up your pencil and you have to move to the next point. And that would be this one. You have to draw it to the left and to the right. So to the left, what has to happen? Has to go down, right? Can't go up. So it's got to go down. And as I draw it to the right, what's going to happen? I've got a bunch of connect dots, right? So here to here, back, down, back up. And then when I get to this point, it's going to have to continue to go up, right? You can't turn back down and cross through the x-axis, so it's going to go up. That almost looks like a polynomial in there, doesn't it? Difference is that we have these barriers, so our function's stuck between those two walls, right? Polynomials, they just kept on going. These are stuck. A what? It's a roller coaster, that's right. Yeah, that would be pretty fun, huh? All right, so I pick up my pencil, I go to the next point, to the left.
It's got to go down.
It's got to go down. To the right, it's almost a reflection of what's over there, right? That's it.
Just realize, like in general, like if you just split it, like looked at it as a reflection across x equals 0, then that would work too. Just the particular way you do it.
Yeah, it's almost a complete reflection, almost.
Or not like that, but you know, like if you flip it both ways, you know what I mean.
I think so. The only difference is that this one, if you flip to the other side, would be -6, and that one would be +5. So it would be a little bit off, but I get what you're saying. All right, that okay? All right. Let's do something a little more exciting. I have an idea. That can't be good.
Last time we had a test.
When you click something that says advanced, it's not looking too good for us.
We're due. Hey, we haven't even done them.
No, we have not. We've done that, though.
We just did that.
That one looks a little too easy.
Yeah,
Okay.
When I give it a harder one,
I am going to.
Are you gonna do this on our own?
You want to? You want to try that one? Okay. So you asked for it. Oh, no, no, not that one. Hold on.
He said that was too easy.
Is making the problem go bigger.
I know. So it would be like x to the 12 minus negative 27 and a half x.
To the 9. To the 9, we just threw us a couple.
Divided by the sun's divided
Okay, here we go.
Divided by pi. No, divided by pi x cubed.
There we go.
Still an elephant. You just draw an elephant in the middle of the guy.
It's like, let's make the math become letters. And pictures.
They ran out of letters, so they just started drawing
Every
animals.
time someone asks me about it, I pass it off.
Solve for giraffe. Solve for giraffe.
What? And I'm like,
Like making it too long to do.
is that funny? No, that's not funny. That's funny. Okay.
4, 5, 6.
That's so.
Don't worry about it, guys. It's close to 1.
Oh, this is good. I'm not going to do that to you. Hold on. I'll just do this. There. All right. Be careful. Take your time. Pay attention to what you're doing. And, talk to each other. Help each other out. I'm going to give you some time on this one.
I'm still ready to have a problem.
No more grading for me right now. I'm buried right now under grading.
The answer was only the answer.
It's like, I gotta say,
I usually stay on top of it, but I am so behind right now. Got a lot of things going on.
if everybody aims, it works out a lot.
We could do that. Just give you your degree.
Hey, that's a good idea.
All right, get to work. Is that the first one that works? It is? Yeah. -2 should work.
Yeah, I messed up in the beginning, so I was going all the way to like 7.
Okay.
I found another one. It was 3.
That should all still work, though. Yeah.
But for me, it doesn't have a hole. I don't have a hole.
Oh, because it's the opposite, remember? When you bring this down, it's the opposite of that number, x minus 3 in parentheses. So you notice on my synthetic division, that -2 worked, right? But that means -2 is an x-intercept, which means x plus 2 is a factor. So it's the opposite of this number here. So then you will have the whole.
This isn't fair.
For the record, I gave them the -2, so you have to.
Come on, man. I know, but at least give us some sort of edge.
You what?
I did -3.
We didn't go to biodegree.com.
It didn't work though, did it? -3?
I mean,
On the synthetic?
Biodegree.com.
I skipped -2 because I didn't bother doing it.
-3 should not have worked.
Minor maybe, also mathematics.
Did you try it?
When you add down there, you get 3.
Wait, is it -13?
No, no,
minus
no.
negative
6
13?
minus 3.
Yes?
I thought it was 6 minus negative.
No, you're just adding down. So it's just 3. So that's, yeah, this one should have worked then. See, because when you add down, that should be just 9. You only change it when you're doing long division. That's when you come through and subtract and change.
Synthetic is
Just add straight down the numbers.
not like there's a negative between them.
That's right. That's right. There's no negative. It's just plus. So if you're adding 2 negatives, it'll just add up. Good? Okay. I think it's worth us just reviewing real quick. How many of you at least got to where you got all the information, you think? Yeah? Okay. So look, you look at this, you say, okay, first step, I'm going to factor it. You have trouble factoring the top. But we learned this new way of factoring, so I write out the numerator. make a list of all the numbers. I kind of took a shortcut. I didn't make the whole list. And I took a bigger shortcut by knowing that -2 was going to work. And I got 0 here. And then I used x minus 2 to create the factor x plus 2, and then used those numbers to create the rest. This was a quadratic it factored. So there's my numerator. The denominator was a quadratic. I knew how to factor that, so I just went straight to it. I noticed I had common factors. I canceled them, but I reminded myself that whenever that factor is 0, that means that x equals 3, I'll have a whole. Then x-intercepts, you set the numerator equal to 0. The numerator after you've canceled the whole. So just these two x-intercepts. Vertical asymptote, set the denominator after you've canceled equal to 0. 1 vertical. Horizontal, you go back to the original. This behaves like x cubed over x squared, which behaves like x. As x gets big and positive, well, that just gets big and positive, right? When x gets big and negative, well, that just gets big and negative. So it looks like this. As x gets negative big, the function gets negative big. As x gets positive big, the function gets positive big.
So if it was negative, it would be switched.
If it was negative here, it'd be switched.
Okay,
Yep.
now I understand.
Yes?
Now it clicked.
Okay.
This is a lot of work.
Yes. Okay, now we graph. Well, test points.
A lot of work is wrong with this one.
So let's see if we can put this all on a picture. I'll need your help because I just erased everything. Well, maybe not. I won't need your. If you did your own?
I don't know if you're going to choose it.
Oh, you're all going to choose different ones possibly, and that's okay. We should all get the same general behavior. So I have x-intercepts at -2 and -7. I have a vertical at x is -5. I have a horizontal. I don't really have a horizontal, do I? And I have a hole at 3, so I'll just have to remember that later. Okay, so how about some test points? -6 would squeeze in there real nice. -3 would fit in here. -8, something on the far outside, right? And then something over here, 0. That should work. Just don't plug in 3. Then you're going to have division by 0, aren't you? Like, don't plug in your hole. You should have trouble there. And now you plug each of those in. So I'm going to plug -8 into this right here. And you can plug it into the one that's canceled. That's okay. All right? So if we plug in -8, plug in x is -8, we get negative over negative. And that's positive over negative, that's negative. So I know at this point it goes down. And then at -6, we do the same thing. And I believe it switches. Anyone who's done it, it switches back and forth? Up, down, up. That's all I have.
No, when I plotted 4, it was still,
You did
I did -4, I'm sorry.
You did -4? That should be -4 here gives you negative.
Never mind.
You got it? Okay. All these little things, right, that you have to, I mean, one little thing can throw everything off. All right, so now connect the dots. As I come out to my far left dot, what am I going to do if I draw it this way? Down, because my horizontal, right, I didn't have one, and it said down on the left, up on the right, so it's going to go down. And then it's going to connect to this dot, connect to that dot, and then it's got to go up. Jump to the next one, draw to the left, go down. Connect dots, and then over here, I don't have anything else, so what did the right end do? It goes up, right? So it goes up like this. But there's a hole at 3. So at 3, I just mark 3, come up here, erase, hole. There it is.
Are we gonna like do like more things this time this summer? With the whole and calculus?
The whole is going to be really the heart of what you're going to be doing in calculus, because
Yeah, plug it in.
the whole is where you're getting division by 0, right? And do you remember me talking about the secant line where you had a point and this point, and you want to pull this point over to that one, but when you pulled it over and put it right on top, you got rise over run was 0 over 0? Notice here, if I plug in 3, I get 0 over 0. Calculus will give us a way to get around that. Okay. Good. You all feel okay about this? Question? I don't know. Y'all seem to be okay with this. Yeah, I don't know. That one seems too easy to me. I'm not sure why I'd give that on the test. Maybe I was feeling nice or something. Maybe they weren't. Maybe they weren't keeping up. Maybe they were just. I had to dial it back a little bit. Okay. Do you want to see another one of these, or do you feel like you're comfortable with it? I should probably say that we're going to do rational inequalities next, which is basically just an extension of what we've done here. Do you remember like when we did problems like this? I'm just making this one up.
Yeah, I remember when we did this problem.
Okay. Polynomial inequalities.
Yes.
The first thing we did is we set it equal to 0, and then we said if we could graph it, then I can tell you where it's above and below, right?
Yes.
What we're going to do now are called rational inequalities. So it's going to be an inequality with a rational expression, but these are rational functions. So if we know what the rational function looks like, then we know when it's above and below the x-axis. Same exact thing. Pardon? Yeah, that's what we're going to do right now.
The first thing we did is combine like terms and see if 2x squared.
Yeah, let's just try one and see how you do. All right, let's just take a look.
I think it should be that hard.
Where is it?
Because it's just like combining, right?
Where is it? I thought I opened it. I thought I had opened it. That's Cal 2.
Wow.
I think everybody's ready for spring break, huh? There it is.
One of them told me we had libraries.
Okay.
I'm gonna do that.
All right, so let's take a look at rational inequalities. All right, so very similar to the whole idea of a polynomial inequality, except this time we have a rational expression. So there's a bunch of steps again, but let's just get to one here. Let's look at this first one, A. I want to know when x plus 7 over x plus 4 is greater than 0, right? That's what I want to know. Now let's see how quickly we can move through this, knowing what we know now.
Isn't that like the same thing? You're just gonna find all of the.
Yes, let's see how much information do we actually need. So look at this right here. That looks like a function, and it actually looks like a rational function, doesn't it? And I could ask you right now, without this here, I could ask you to graph that, right? And so what you would do is you would go through and you'd factor out the top and bottom, which in this case it's already factored. You'd find the x-intercepts, You'd find the verticals, you'd find the horizontals, you'd do your test points, and you'd be done, right? Let's see what parts are important to us. When we did this here, we would do verticals and x's, right? And then test points to figure out where we're above and below. The horizontal really does not play into the above or below. The horizontal only plays into like where it flattens out or the behavior at the ends. We still know by just the test points if we're above or below, right? And that's all we want to know here is where are we above the x-axis. Do you all understand that's what that means?
Yeah.
So all that's important to us are just to get the information for the vertical and the x-intercepts. So let's do x-intercepts first. X is -7. Okay, so I'm going to come over here, -7, boom, put a dot, right? Then vertical asymptote, which is, in this case, x is -4. Put that here, -4, put dotted line, right? Like this. Understand?
Is that why you did it that way? You gave us the other one and then.
Yes, that's why I did that. Okay, next thing, test points. Here. What the heck, man? I keep on throwing away these bad markers and they keep on coming back out of the trash or something. X, here, here, and here, right? That's all we need? 3? So -8, -5, and 0. All right, so let's plug these in. We plug in -8. This should be pretty quick. -8 here, negative on top, negative on bottom, positive, greater than 0. Then -5, positive, negative, which is negative, so it's below.
Positive over negative.
And then 0, you get positive over positive, right? Positive.
Positive over 4.
We okay with that? So if I asked you to draw this right now, here's what you could tell me. You know that this connects, and you know that this dives down. You know that this goes up, right? And then on this side, it either flattens out to something or it goes up, right? There's no way it crosses back through. Why? There's no more x-intercepts. So I can just say this and who cares, right? Isn't it over here above the x-axis? Between here and here, it's below. And over here, again, same thing. I don't care, but I know it never comes back down. So over here, it just stays above. Agreed? So can you tell me now where this is bigger than 0?
Yeah. It's negative infinity all the way
It's
to
all of this, right? Forever. And in here, right? Forever. Okay, so let's see how we're going to write that.
Parentheses.
Parenthesis.
Parentheses for all of them.
Okay, parenthesis. Hold on. Negative infinity
No,
to where?
7 equals 0.
-7. Okay, and at -7, we're equal to 0. Do we want to be equal to 0?
Yeah.
No, because of this. Now, if there was a bar, yes, we would bracket it out.
Sorry, I wrote it wrong.
So -7 and then parenthesis. Now, what about -4 over here? Do I include it?
No, you do parentheses.
I don't include it. Why don't I include it?
Because it's vertical asymptote.
That's right. We have to be careful here.
It goes to the closest number to
We could never include -4, could we? Even if this was an equals, we couldn't include -4. Why? You can never plug -4 in here.
Because we're spiteful people
Right?
that reject others.
That's right. So -4 to where? Infinity. That's it. That's your solution. That's your solution set. You pick any number in here or any number in here, and that inequality will be true. So you see how we did that? I mean, basically we fell back on what we know about graphing these things. And we realized we didn't need all the information, right? But we needed a big chunk of it. X-intercepts, verticals, some test points, and we were in business.
This is a lot easier than the, I mean, it's less tedious as far as.
Let's do another couple of examples. Okay, let's look at the next one.
I'm sure you think it was more complicated.
You want to try the next one? Okay, you try the next one.
Number B?
Number B, yes, number B.
B is my favorite number.
Do number B. After that, we'll do letter 4.
All right. Before we start, on a scale of 1 to 10, what is your favorite color of the alphabet? For me, it's probably 1.
I like chicken.
That's a pretty good choice, too.
All right, see what you can do on that.